Okay, welcome back. So last time we looked at kind of enzymes and substrate binding, activation, catalysis. We're going to look at a different type of catalytic macromolecule in a cell now. And if you've taken general biology with me, then you've probably heard me talk a little bit about the ribosome as an example of a ribozyme. So we'll look at that in a moment, but let's look at a different example to start with. We'll look at ribonuclease P in a moment. There are certain catalytic RNA molecules in cells, and I'll give you 3 examples. We'll take a look at them in a moment. And these catalytic RNA molecules are called ribozymes, and so it's just not enzymes that are catalytic in cells, the protein-based enzymes at least. There are some catalytic RNA molecules as well. These were discovered in the mid-1980s, and there's pretty good evidence that these were some of the first catalytic molecules on Earth in that prebiotic soup you hear about. So let's look at 3 examples. First one here on the left is ribonuclease P, and that's a ribosome that is involved in the maturation of transfer tRNAs to produce the functional form of the tRNA that can carry amino acids around the cell. So ribonuclease P cleaves the tRNA to produce an active form of that molecule. And so as well as the RNA in ribonuclease P that's catalytic, there's a protein scaffold as well, and you can see the RNA molecule in this ribbon structure in the background, and then you can just see a shadow of some protein component as well. So always important to bear in mind that these ribosomes are often complexes of RNA and protein, but it's the catalytic piece we're interested in. That's the RNA component in some of these catalysts. Probably my favorite example here of a ribozyme is the ribosome. And so in terms of the part of the ribosome which is the catalytic part, that's the part that does peptidyl transferase. That's the part that moves the amino acid from the tRNA in one site onto the growing polypeptide chain in the other site. That's actually done by an RNA molecule, the large RNA molecule in the large subunit of the ribosome that actually does the chemistry of transferring the amino acid from the tRNA onto the growing amino acid chain. And here in this ribosome, you can see the catalytic RNA in orange. There's another RNA in the back here, and then there's a lot of proteins not shown. A few of them are shown here in purple. Lots of proteins that scaffold around the catalytic RNA. Another nice example is the SNRP, the small ribonuclear protein or particle, really, that's involved in the splicing of introns in RNA processing. If you remember back there, that's one of the steps of RNA maturation where you have capping, tailing, and splicing. The SNRP that you may have heard about, the molecule which is involved in cutting and then rejoining the exons together in RNA maturation in splicing. The catalytic component of the SNRP is an RNA also. So that's all that I think is kind of important about ribozymes. You can read about the history of this in your book and stuff. Their catalytic RNA molecules often work in complex with protein. So that's enough on ribozymes. We'll see you next time when we're going to start getting into a little bit more math again and looking at some enzyme kinetics. I'll see you soon.